Today we're going to continue learning how to solve exponential equations in logarithmic terms. So here we have an equation where our x variable is in the exponent and we want to get it out of the exponent. So we did learn the one-to-one property that said if we could make these two numbers look the same, we could cancel them. Unfortunately, there's no way for me to make 7 look like 3. So the only way that I can solve this equation is if I rely on my log properties. So on the right-hand side here, I'm showing you the log property that we would want to use here. So remember that if I multiply a number b by a log with the same base, the base and that number would cancel, leaving me just with what's in the exponent. So what that looks like for us, since I want to get rid of the number 7, my base should be 7. So I would write out log base 7 of 7 2x minus 5. And remember, if I do it to the left, I have to do it to the right. So this would also be log base 7 of 3. And again, according to our log property shown right here, the log and the number in front of it would cancel, and all I'm left with is the exponent. So I will strike through all of this, and I'm left with 2x minus 5 is equal to log base 7 of 3. And now I simply just want to continue solving this problem and isolating x. So I have 2x is equal to log base 7 of 3 minus 5, and x is equal to log base 7 of 3 minus 5, and all of this would be divided by 2. I would like to make one more note here. If you were to try to plug this into a calculator, you would not be able to solve this problem. And the reason is because on a calculator, the log button is always base 10, and this here is log base 7. Same thing if you try using Desmos. Desmos doesn't let you change the base either. So the only way to solve this problem is if you use the change in base formula. And the change in base formula simply says if you have a log of base b times x, if you rewrite that as log of x up here at the top divided by log of b down here at the bottom, with your new base being 10, you get the same exact answer. So all we did was we took one log and we turned it into two separate logs, each base 10. The number inside the parentheses is the log on top. The base is going to be the number inside the parentheses on the bottom. So to finish solving the original problem that we were working with, I'm going to rewrite this using change in base. So this actually equals log of 3 log of over log of 7, and both of these are now base 10, so I can just plug them into the calculator, minus 5 divided by 2. So once I plug this into the calculator, x equals 2.78 rounded to the second decimal place. We're going to go ahead and do one more problem using our logarithmic properties like we did on the previous page. Here, to start this problem, we need to clean up the left-hand side of the equation a little bit. So some of us might think, hey, let's distribute this 3 here. But I actually want to work with smaller numbers, not larger numbers. So I'm going to go ahead and divide both sides of the equation by 3. So if I divide the left-hand side by 3, I'm left with 2 raised to 7x minus 9. And on the right-hand side, 27 divided by 3 gives me 9. So now, again, if I look at my two base numbers here, 2 and 9, there's no way for me to convert this 9 into a 2. So instead, I'm going to have to use my log properties to get rid of this 2 and to get x out of the exponents. So I'm going to go with log base 2 of 2 raised to 7x minus 9. And if I do it to the left, I have to do it to the right. Log base 2 of 9. Since my base is the same and this 2, the number in front of the log, is the same, all of that is going to cancel. And I'm going to end up with 7x minus 9 is equal to log base 2 of 9. And now we're going to go ahead and solve for x and isolate it. Solve for x and isolate it. So I get 7x is equal to log base 2 of 9 plus 9. And then I divide both sides by 7. So I get log base 2 of 9 plus 9, all divided by 7. And remember, I can't plug this into the calculator because my calculator only does log base 10. So I need to rearrange this using change in base formula, giving me x is equal to log of 9 over log of 2 plus 9 over 7. And remember, both of these are now base 10, so I can just plug that into the calculator. And my final answer is x equals 1.74 rounded to the second decimal place. Following this video is one more video on how to solve exponential equations, and then after that, there's a set of problems. All of the problems are mixed because I want you to figure out which method you need to use to solve the equation, and this is all to get you ready for your upcoming exam. Good luck.